Hi, pre-calc honors. So welcome back. So this is 3-8. Oh my gosh. 3-8, meaning that we are very, very close to being done. All right, y'all? So let's start. The unit is called derivatives of inverse trigonometric functions. Okay. This unit's a little bit confusing, so make sure you pay attention. So let's start with the derivative of an inverse function. So let's recall that the inverse function is the result. Oops, you can't see out the way. Is the give me a second. There you go. Is the result when you switch the domain and range from the original. Okay. So this thing is spelled original. So for example, let's start out with original function. Our original function. Let's give you something really simple. Y equals x to the third. If I switch x and y, domain and range, I now have x equals y to the third. Okay. This is exactly the same as or equivalent to the inverse. We, in math, or basic math classes, normally we like to write the function in terms of x, right? So that's why we normally want to solve for y, because we want y equals. So when we solve for y, we are going to take the third root to both sides. So y equals third root of x. So this is really our inverse, okay? So this is equivalent to that. This is the result because that has to happen. Same thing with sine. If I give you f of x equals sine of x, I can switch x and y. So this is now x equals sine of y. Okay. Then I need to compose both sides by sine inverse. So when I do that, I end up with an inverse function of sine inverse of x. Okay. This happens. These two are equivalent. Okay. But this happens because this is true. So what if I want to compose the inverse with the regular? So star number one, let's compose f with f inverse. Okay. When I compose f with f inverse, it should come out to be x always, as we remember about the unit in first semester. Okay. Same thing with if I were to compose star number two, f inverse with f. It should always come out to be x. So these two, and let's use and, okay, these two must be true. If these two are true, then f of x and f inverse are inverses of each other. Okay. So how does this work if I want to take the derivative of the inverse function? So here we go. Let's just do this piece. I'm going to use, I guess it doesn't matter. Okay, let's use one of them. Eeny, meeny, miny, mo. Okay, let's just use this. Okay, so here we go. Let's use f of f inverse of x equals to x. Okay, so this is the composition with the inverse being inside of my regular. It equals to x. So let's take the derivative of this. I'm going to use a chain rule for this piece. So the chain rule is going to say f prime of the inner component, okay, f prime of the inner component times the inner component derivative. So I'm going to write it out, okay. So the chain rule says when you have a composition, we're going to take the derivative of the outer component with respect to the inner component times the derivative of the inner component. We're going to take the derivative of x, which is going to be 1. You got it so far? Now, remember, I want to solve for f prime, the derivative of this. So this is what I want to get by itself. Okay? So the derivative of the inverse, because this is really inverse notation right here. That means I'm going to divide both sides by this piece. So divide both sides by f prime of f inverse of x. What I divide to one side, I have to divide to the other. And look, the notation is really confusing, so make sure you pay careful attention and write it correctly. This is the derivative of the outer component, and this is the inverse, okay? So that is now gone. So the derivative of an inverse is this formula, which you will need to memorize, or you can derive it from the original, okay? So the derivative of the inverse, I'm going to write this bracket with the prime, equals to this equation, 1 over f prime of f inverse of x. Okay? And I'm going to highlight it because you're going to need to really know it. And that's how we came up with it. Okay? So let's do a couple of examples, and then maybe that will make sense of how to use this. I'm giving you a polynomial, f of x equals x to the 5th plus 2x to the 3rd plus x minus 1. This is easy, okay? Let's find f of 1. So f of 1, we're just going to plug it into this equation. Let me zoom in. Is 1 to the 5th plus 2 times 1 to the 3rd plus 1 minus 1. Well, plus 1 minus 1 is going to be gone, okay? So 1 to the 3rd is 1. 1 times 2 is 2. 1 to the 5th is 1. So 1 plus 2, I'm going to end up with 3, okay? So f of 1 equals 3. Box that up. This is the input. This is the output. The next part of the same, in the same question is find f prime of 1. Well, to find f prime, I need to find f. To find f prime of 1, I need to find f prime of x. So this is going to be 5x to the 4th plus, bring down the power, so that's 6x squared. This is going to be a plus 1. Derivative of a constant is 0. And then now I need to evaluate it at 1. Okay, so f prime at 1 equals 5 times 1 to the 4th plus 6 times 1 squared plus 1. Well, 1 to any power is just going to be 1. So now this is really 5 plus 6 plus 1. So this is 12. So f prime of 1 is 12. Okay. So that's how we come up with those solutions. Now, on the other side, I would like for you to find f inverse of 3. Well, remember, the inverse function is when you switch the domain and the range, and you switch the range and the domain. If this is currently input of the regular f function, then this is your output when the input is 3. So check that out. F inverse of 3. This is input for the inverse. That means it should be the output for the regular. I already have this order pair, so all I do is switch them. Okay? So that's how easy it is if you know where to look. Now this one, f inverse prime of 3. Okay? This one, based on your formula, so let's write the formula down first. F inverse of x. Okay? And if I were to take the derivative of it, let's write down the formula. It's really 1 over f prime of f inverse of x. Okay, this is the formula I'm going to use. Well, f inverse of, remember, x is evaluated at 3. Okay? So, you need to find out what this is. So now I'm going to take this out and put it in my input. Okay, so 1 over f prime of inverse of 3. Okay? So that's what I'm trying to evaluate when x is 3. Well, I kind of know what that is. I found that right there. F inverse of 3 is 1. So this is really now 1 over f prime of 1. Right? So that's the inner component. And I found, okay. So now I need to find out what the derivative at 1 is. Oh my gosh, it's right there. Okay? So the derivative of f at 1 is 12. So this whole thing comes out to be 1 over 12. But you do need to be cautious of taking each inner component and then spread it out to the outer component. Okay? Let's make it zoom in a little bit. Okay, so I'm going to give you the derivative of sine inverse. Arc sine and sine inverse is the same, so this is y equals arc sine, which is the same as y equals sine inverse. I'm sorry, arctan of x and sine inverse of x. Okay? Okay, so here we go. D, the derivative with respect to x, over sine inverse of u is 1 over square root of 1 minus u squared times du over dx. Okay? So we can box that up. And if you don't feel like using du over dx, you can also do this. The derivative of sine inverse function of u equals 1 over square root 1 minus u squared. You can also multiply this by u prime. U prime is the same as du over dx. Okay? Provided that the absolute value of u is going to be less than 0. The reason if it's not less than 0, then there's going to be a negative under here. So I can't have that. Okay? So that's your formula for the derivative of sine inverse. Make sure you highlight it, and you really do need to know it. Okay? So I'll highlight it for you. Okay? I'm going to flip over, and if I'm going too fast, go ahead and hit pause so you can finish writing. Alright, now let's go and do example 2. Example 2, find the derivative of y equals sine inverse of 1 minus t with respect to t. So we don't have x, but that's really not important. So the first thing I'm going to do is let u be 1 minus t. Then I'm going to ask you to do u prime for me. Can you please take the derivative of u for me with respect to t? So u prime, hopefully you wrote -1. Okay. So right now I'm going to write y equals sine inverse of u. And you're asked to take the derivative, which is really y prime. So the derivative, according to the formula, is 1 over square root 1 minus u squared times u prime. That's the formula. From here, we're just going to plug in u's and u prime. So it's going to be 1 over square root. U is going to be 1 minus t. So copy the 1 over. Minus u squared. So that's really 1 minus t. Times u prime is going to be -1. Then from here, I'm just going to put this -1 on the top. So now I have -1 over square root 1 minus, I'm going to multiply this out. 1 times 1 is 1. In the middle is -2t plus t squared. Okay. Then I'm just going to simplify some more. On the top, I have -1 over. When I distribute, those will cancel. Okay, but I'm just going to write it out first. How about that? This will be 1 minus 1. -1 times a -2t is +2t. a negative 1 times a positive t is minus t squared. I'm going to end up with 1 and 1 will cancel. So I have 2t minus t squared. Okay. So now in theory, I can definitely factor out a t, but it's not going to help me get it out of the radical. So guess what? I'm just going to leave it as is. And guys, this is the derivative of this equation. So this is dy over dt with respect to t. Okay. All right, 2 more equations to memorize. Okay. The derivative of tangent. So let's give you y equals tangent inverse of x, or let's use u, which is some books will use y equals arc tangent of x. Okay, so tangent inverse, let's use u since I'm using u. Okay, so y equals tangent inverse of u is the same as y equals arc tangent of u. Okay, so with that, derivative sets derivative with respect to x, okay, of tangent inverse of u is 1 over 1 plus u squared times du dx, which is the same as 1 over 1 plus u squared times u prime if you don't feel like using du over dx. So either one is perfectly okay to use. They're identical. It's just a preference of, hey, do you want to write u prime or do you want to write dy dx? I'm sorry, not dy, du dx. Okay, so highlight this. Okay. Third equation for the inverse, y equals arc secant of u or y equals secant inverse of u. Okay. The derivative sets d with respect to x, by the way. If you have secant inverse of u, you can have this. 1 over absolute value of u times u squared minus 1 times du dx, okay, because I'm taking with respect to x, not u, or 1 over absolute value of u times u squared radical minus 1, the radical of u squared minus 1. If you don't feel like using this notation, du dx, you can just do u prime, provided that absolute value of u is greater than 0. So these are the third inverse formula that you must know. And I'm just going to highlight it all. Okay? This is multiplication. All right. Now with that formula written in, let's do our example 3. This is the last one in this video. You are provided y equals secant inverse of 5x. So what I'm going to do is let u be 5s. Okay? Then u prime is 5. So I want to take it with respect to x. So dy over ds of secant inverse of u. Okay? Secant inverse of u. Here we go. So it's going to be, according to my formula, it's right here. I'm going to write the formula first, okay? 1 over absolute value of u times u squared minus 1 times dy dx, or in this case, you can write u prime. Then now I'm going to fill it in. 1 over absolute value of u is going to be absolute value of 5s. Okay, u squared, so that's 25s squared, minus 1 times u prime, so u prime is 5, so that's all out there. Let's make it pretty. I'm going to put this in the numerator, so that's 5 over absolute value of 5s. Absolute meaning that I'm just going to make everything positive, but 5 will always be positive, so you can definitely take that out. Square root of 25s squared minus 1. Well, the 5 and the 5 can cancel, so now I'm going to end up with a 1 over absolute value of s times square root of 25s squared minus 1. And looks like that's all I can do. I can factor this out because it's a difference of two squares, but it's not going to help me simplify it. Okay, so that's all we are going to do for this video. Did I tell you a joke yet? I should, huh? Here we go. A joke for today. Gosh, what should I tell you? Okay, why did the thief take a shower? So why did the thief take a shower? He wanted to make a clean getaway. All right, I love you guys, and I'm so proud of you, each and every one of you. Have a wonderful day.